Okay, in this video, we will discuss about ductile to brittle transformation. So we have seen what is a ductile fracture and what is a brittle fracture. Okay, let us draw that once more here. Okay, so you have the ductile fracture here, and so this is a stress strain curve. And here you have the ductile fracture, and here you have the here you have the ductile fracture. Okay, this is the ductile fracture. And here you have the brittle fracture. Brittle fracture. See, towards here you have very little plastic deformation. Very little plastic deformation. And in ductile fracture, you have a uh, plastic deformation. There is significant deformation. That is the difference between these two. Okay, significant plastic deformation. Significant plastic deformation. That's the main difference between these two. But see, this temperature can causes this ductile fracture. The materials exhibiting the ductile fracture can fracture uh, in this behavior also can have brittle behavior due to some transition due to temperature. Okay, due to some transition temperature. To understand this, let us do some impact test. Okay, that is Charpy impact test. So this test is conducted to measure the ductility of the material. So here in this test, you have a instrument like this. Here it is centered here, and then here you have your specimen kept here. Okay, specimen kept here. So here, the specimen kept here. So it is fixed here. See, when it is left free, okay, so it will strike it and it will break. And uh, here, so this will be released at a particular height. So it will be at a particular height h. So let this be the base height. So this is released from a height h, and this will okay. So you can measure the final height. So here, so this will be hf, and here it is hi. So the difference in height, that is hi minus hf, can be noted. So that means the difference in height. See, before release, it had a potential energy of mghi. So after release, the finally it has got a potential energy of mgHf. So difference in potential energy is the energy absorbed by the material. That means if for a ductile material, it will absorb more energy. That means its toughness will high. Its toughness is high. It will absorb more energy, and it is much more ductile. That means, and if this energy is very low, that means it shows a brittle behavior. It is very low, that it shows a brittle behavior. Okay, in this way you can measure the ductility of a material. So this is called the Charpy impact test. And so I am doing an experiment here, that is a Charpy impact test. So here it is. um, In the y-axis, I am measuring this impact energy. Okay. And in x-axis, I am noting down the temperature, that is minus 200, minus 100. Okay, here 0, here it is 100, here it is 2. So that means basically I am measuring the ductility of a material at different temperatures. Okay, that means I keep the material at different temperatures and then I am testing the ductility. So what I observed was that you can see for a material, that means with 0.01 weight percentage carbon, that is a ductile. See, this here the impact energy is very high. That means for a temperature up to 0, see, after that, after some around 75 degrees Celsius, see, this steel has a transition from ductile to brittle behavior. So the transition is sudden. Here you can see that below that temperature, it is somewhere around minus 75 and minus 30 degrees Celsius. You can see this transition, ductile to brittle transition. Okay. So I did this experiment with another steel, that is, it has got a carbon content of 0.28%. I increased the carbon content. So what I saw that here also I had a transformation. Okay. See, here the transition is comparably gradual. In earlier case, with a low carbon content, the ductile to brittle transition was sudden. Here it is quite gradual. So I did it with another specimen, that is zero point 0.4 weight percentage carbon. Okay. So you can see that it is still more gradual. So for 0.2%, you can see that its impact energy is low. That means it is brittle compared to this 0.01 weight percentage carbon. But you can see that its transition temperature is not sudden. It is quite gradual. As you reduce the temperature, it is becoming much more brittle, but it's in a gradual way. So this is called ductile to brittle transition. And the temperature at which this transition occurs is TDBT, or you can call it ductile to brittle transition temperature. Ductile to brittle transition temperature. Transition temperature. Right. So the temperature at which the material will transit from change from um, ductile to brittle is called the dry is the ductile to brittle transition temperature. So that is why the Titanic, the material was steel. It had a ductile behavior at high temperature, but when the temperature was very low, the, the had a brittle fracture. Okay, because of this ductile to brittle transition, the steel exhibited brittle fracture at that temperature. So that is one reason why the Titanic sank. Okay. Now let us write draw another graph here. That is here the y-axis you have sigma f mm, or sigma y, okay, yield stress, or sigma y, that is fracture stress. And the x-axis you have the temperature, right? So we have already drawn the fracture stress. Okay, so let us show the fracture stress will vary like this, that is sigma f, or the fracture stress. What is the relationship between the temperature? You can see that at temperature decreases,